Ladies and gentlemen, welcome back. We're now going to be doing some videos on Algebra 2.4. Specifically, we are going to be looking at inequalities in quadratics, how they look, how we solve them, and what they look like in graphing format. After that, I'm hoping to be talking about a few other topics so that this list of topics can go away. I've been on this, I think, for like 3 videos now. So first things first, when we are looking at our little list here, we want to start with the easiest ones first and then sort of get ourselves comfortable with what we're actually doing. 2 of these topics are very similar, so these 2 are basically the same thing, and then these 2 topics are basically the same thing. So even though there's 4 topics I'm giving you, there's only really 2 strategies that we're working with. So to begin, let's talk about some inequalities. And for once, I'm actually not going to zoom in all that much because I want to show you how similar these 2 topics actually are. What's ultimately looking for here is we're going to keep an eye out for our less thans and our greater thans. I'll explain that in a second. First things first, this here should actually look pretty familiar based on some regular topics, because the question you ask yourself is it set to 0? And yes it is. So now all we have to do is set our individual pieces to the 0. X minus 6 equals 0. So we're left with x equals negative 4, because we minus 4, and then we add 6, x equals 6. So what does that tell us? We know we have negative 4 on one side and we have 6 on the other side. We know that because of the type of, let's do it this way, that way, and then that's going to close. We know that since this does not have a line underneath it, that this is going to be an open circle, so open circle on negative 4, open circle on 6. And then the question you have left after that is, which way am I supposed to actually shade? Like, do I shade on one side? Do I shade everything? How does this logic? So here is your little cheat sheet. If it is less than, the way it is over here, you are shading between your points. If it is greater than, you are shading outside of your points. So here, less than means we're shading between. So this is the parts of the number line that I would end up shading. Let's go through another example. This one again, we set our 2 pieces to 0. So x plus 4 equals 0. Solve x equals negative 4. X minus 1 equals 0. Solve x equals 1. So we have, this is has the line underneath it, so it's going to be closed. It's going to be closed at 1 and at negative 4. And since it's a less than, and we have this handy little sheet for us, if it's less than, we're shading between, and therefore we are shading between. And you're starting to realize that the topic itself actually isn't all that hard. It's pretty straightforward when you're looking to it. And, oh, I didn't give myself room. So for this one, we have x equals negative 7 and x equals 2. I'm getting good enough at these by this point that I don't even need to do the separate setting equal to 0, because I'm good enough now that I know that I'm basically flipping the sign. So I have negative 7, I have 2, this is going to be closed because it's an or equal to, and now this one says greater than. Greater than means we're shading on the outside, so greater than means that I'm going to be shading this way, and greater than means that I'm going to be shading this way. So less than, you're shading between, greater than, you're shading the outsides, all right? So then if we look at, that's when it's written in factored form, right there in bold letters. Here it just says writing a quadratic inequality. The written in factored form is not there. So then what do? Well, if I zoom in, this I will zoom in for because I want to give myself some space to write. If I look at this, the question you're always going to ask is it set to 0? Is it set to 0? In this case, the question is no, so we have to go through just a tiny little bit of algebra. So plus 8, and all of our numbers practice their annoying social distancing, so we want to keep them all separate, less than 0. And now this here, this should look pretty familiar because this is what you were doing earlier in the chapter. You are now factoring. So let's just make a quick table in case you need a reminder. Let's see here. This will be same sign. Remember that second term tells us it's going to be the same sign. it tells us what the sign is going to be, which is plus. So it's x plus something less than 0. What are our factors of 8? We have 1 and 8 and 2 and 4. Which one adds up to 6? 2 plus 4 equals 6. So we have 2 and 4. So our numbers are going to be negative 2 and negative 4. So negative 4 and then negative 2. They're open because it's less than, and because it's less than, we're shading between. And I'm starting to talk a little bit faster because the work should be a little bit familiar. You've been doing in Goal 4 the same 2 to 3 things over and over and over again. If you're really lazy and you don't feel like setting up all of your factoring tables, you can also use the quadratic formula. Now, for this next one, you take note. Is it set to 0? No. What I like to do, this is where Ms. Dubois gets a little picky. I don't like my x squared being negative. I find that just mentally hard to break down in my head. And if the human calculator has trouble with it, I don't want students to suffer for it. So we're going to take the x squared, move it over. We're going to take the 2x, move it over. Cancels, cancels. And what do we have? We have 0 greater than or equal to x squared minus 2x minus 3. Again, that minus 3 is not a like term to the x squared or the x because of reasons. Let's see here. X is going to be less than. Let me rewrite that a little bit because every problem we've done, the one up here and also the ones over here and over here, has had the 0 on the right. And I have seen in the past students who look at this and get a little bit confused. So to make things easier for you, we're going to flip this around. So x squared minus 2x minus 3, 0. 0 is the bigger number. That's the one that's being eaten, so the inequality has to eat the 0. And look, it's a less than. That means we're going to be shading between. So let's get there first. Let's do a quick review of our factoring. We have x and x. This here tells me it's opposite sign, so I have a plus and I have a minus. So let's see here. There's our minus, and then we're looking at factors of 3. There's 1 and 3 and 3 and 1. We're looking for negative 2. 1 minus 3 equals negative 2. This is the one we're looking for. So 1 is on the outside and 3, right? Oops, did you see that? Did you see the mistake Ms. Dubois just made? She wasn't paying attention. There we go. So the outside is plus 1 and the inside is minus 3. See, Ms. Dubois, what happens when you try to rush? Silly Ms. Dubois. So flip our signs. Our numbers are going to be 3 and negative 1. So we have negative 1, 0, 1, 2, 3. We're going to be closed because it's an or equal to, and we just learned that this is a less than, so we're going to be shading between, and that's what your answer should look like in the software. One more, because I noticed this one pop up when I was looking for sample problems for you guys, and I realized, ooh, gotta make sure we get this covered. So, same old, same old. Is it set to 0? No. So we're going to minus 4x minus 4x. That leaves us with x squared minus 4x greater than or equal to 0. I've had more than a couple of kids who see a version of this kind of factoring and they don't quite understand what it is that they're doing. Here's what I want to point out. You have the x squared and you have an x. So that means this has 2 x's here and this has 1, which means you have an x in common. If you have that x in common, then therefore you can pull it out to become x parentheses x minus 4 greater than or equal to 0. And that might look familiar because I did cover this in an earlier video. What's happening here is you're going to set each piece to 0 and then x minus 4 equals 0, x equals 4. And look what happened here. Because this x happened to be all by itself, there was no extra work that we needed to do. We knew actually, in fact, that one of our numbers was 0. And then the next number is going to be 4. Let's see here. These are going to be closed because it's more equal to, and it's greater than, so we're going to be shading on the outside. And that is how these two topics are done. The work itself is actually almost painfully straightforward. There's not all that much in the way of difficult thought. If any of you guys had forgotten factoring, this is a good place to review it because again, it pops up kind of over and over. The next main thing, so these two topics are now done, check and check. The next thing we want to talk about is graphing the quadratic inequality. The The thing for these, for both of them, is they have a button in the software that looks like a parabola. And this is the hate part of the love-hate relationship, because this button exists and they did not give it to you until now. Roar horror. Okay, here's what's going to happen. First things first, let me zoom in on a particular problem. No, that's a little too big. Alright, so when we're looking at this, instead of saying, is it set to 0, you're asking yourself, is y by itself? Because now we're looking at this in terms of graphing, and we want it to look as close to y equals mx as b as we can. So the y is not by itself, it's not under quarantine, because that x squared is there, and so we got to take the x squared and we got to remove it. X squared. So we're left with y greater than or equal to x squared minus 4. And now you can kind of see, based on the two different problems, that they have a very similar setup. They look very close to each other. And what's happening now is that you know what your y-intercept is. That minus 4 is the first point of my parabola, the vertex of my x squared curve, which is called a parabola. When we're looking at this, do we have any special things here to worry about? Nope. So we have something called a 1, 3, 5 sheet. Now, because you have this button over here in the software, we don't have to worry about it here, but since I don't have it, since I'm making a video, this is a good chance to talk about how we can make this work to our advantage when we're graphing this hardcore. What this means, if I look, let's ignore for a second the y-intercept. Let's assume that I'm starting at my absolute base terms, y equals x squared. Y equals x squared. I'm starting 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, which I don't have enough space for. Negative 1 times negative 1 is positive 1, negative 2 times negative 2 is positive 4. And then there's the base shape of your parabola. Most kids can kind of pick up on that because they can at least work through that much in their heads, because this is a throwback all the way back to a 1. But there actually is a pattern here that I want to point out to you. When I'm looking here, I went up 1 square. When I look, I went up 1 square. From here to here, I went up 3 squares. If I'm going from 4 all the way up to 9, I'm going up 5 squares. That's where the 1, 3, 5 rule is coming in. My next one, I would go up 7 squares. Then I would go up 9, then 11, then 13. There's a pattern there when you're doing that kind of thing. And you can use that to your advantage both here and then also later when you're graphing more complicated quadratics. So since I now know that, I don't have to worry all that much about anything other than my y-intercept. Okay, sorry for the quick break, had to answer a phone call. Alright, so now where are we at right now? So we know now that our y-intercept is negative 4, so we're going to put our little dot on negative 4, and now we have this 1, 3, 5 hack, I guess is the word I want to use, that comes to our advantage. So we're going to go up 1 over 1, up 1 over 1, up 1, 2, 3, over 1, over 1, and then for this one, just to show you how that works, up 1, 2, 3, 4, 5, over 1, and then over 1, and we're doing our mirroring, and there's the basic shape of your parabola. Ta-da! Again, this button exists in the software, so all you have to do is click your first point here on the x-axis, and then you just move your parabola around so that it matches the shape you want, which basically means you'll be clicking again to make sure that it's opening up, and then you're going to be clicking again to make sure that you're going up 1 over 1, and it should make your parabola automatically. Over here, same idea. There's no extra work here because they decided to be nice to you. Our y-intercept is negative 6, so we're going to start down there. Up 1 over 1, up 1 over 1, up 1, 2, 3 over 1, over 1, up 1, 2, 3, 4, 5, over 1, over 1, and then there is your parabola. So that's problem type 1. You can see it up here on the screen. The question then is, how do you do it when it's not quite that simple? And yet again, this actually should look a little bit familiar because you've done versions of this in earlier topics. It's the same old, same old. So what are we going to be looking for? We need our vertex. funny. How do we find vertexes again? What's that thing that we have been using over and over in the last couple of videos to figure out what our x and y are? Oh yeah. So let's see here, label these. That's A, B, and C. So it's opposite B, so negative 12 over 2 times A, and what's our A? 2. So negative 12 over 4, which is negative 3. So my vertex here is going to be negative 3 comma something. Now we got to figure out the something. Well, what do? We take the negative 3 and then we plug it in. So 2 times negative 3 quantity squared plus 12 times negative 3 plus 19. So negative 3 squared is 9 times 2 is 18 minus 36 plus 19. 18 and 19 is 20. 37 minus 36, 1. Okay, so there is our thing. Negative 3, 1. There's our vertex. And then that 1, 3, 5 rule that we were just talking about over here, we are going to use it, but we're going to now change it just a little bit with that too. So we're going to be 2 times 1, 2 times 3, 2 times 5. So we're going to go, instead of up 1, we're going to go up 1 times 2, which is 2. So we're going up 2. Here. So now we're going to be going up 2, up 2 times 3 is 6, up 2 times 5 is 10. So let's see here, 6. 1, 2, 3, 4, oh, I didn't give myself enough room. 5, 6 over 1, and then over 1. And this is true in the software as well. They don't always give you enough space. But again, for these two topics, graphing and linear inequalities, this button exists in the software and it will do all of the work for you. So instead, the only thing that you're keeping an eye out for is making sure that you're going up 2 over 1. Over here, same verse, same new verse, same as the first. That's the phrase, right? That's what you young hip whippersnappers do be saying. I just embarrassed myself. I'm going to ignore that. All right. So what do we have? Opposite B over 2A, so positive 12 over 2 times 2. Really? Oh, wow. Look at how close the two problems are. I didn't even notice that when I was doing my screen grabs. All right, so that'll be 12 over 4, which is 3. So it's going to be 3 comma something, And now I plug it in. So 2 times 3 squared minus 12 times 3 plus 21. Let's see what we get. So 3 squared is 9 times 2 is 18 minus 36 plus 21. That's going to be 30, 40, oh my god, 18 plus 1, 39. Wow, Ms. Dubois can't math this morning. It's almost like she didn't get sleep or something, so that's going to be 3. So 3 comma 3, 3 comma 3. There's our vertex. Our slope is 2, so we're going to use our little handy dandy button, make our parabola, and then, hey look, that almost looks like a PA problem. I wonder if using just only 3 dots was something Ms. Dubois knew would be advantage back at the beginning of the school year. But anyway, back to task. So where are we at right now? That is 4 more topics we now have comfortable under our slate of things to do. So next video, we're going to finally be looking at a different collection of families and topics for Goal 4. There's not that many critical topics left. There's a couple of topics for me to touch base on, some of them DSA related, and that then we should be almost done with Goal 4. As a reminder, quarter ends April 7th. You need to be, as of this moment, 50% through Goal 4 in order to pass for the quarter. More on that forthcoming. I'll be sending out an email later today. In the meantime, stay happy, stay healthy, stay safe.